Hi, this video is to talk about interval estimation for a population proportion. So what we are doing is building an interval estimate that might include the true population proportion, and we're going to be using sample data. So this is the general view of the formula to come up with the interval estimation. We have the sample proportion and we add and subtract a margin of error. So this margin of error for proportion is the z-score associated with the alpha level divided by 2 multiplied by the standard deviation of the sample proportion. Remember, you learned this in chapter 7, this you learned in chapter 8, this is very simple, you learned in chapter 3, okay? So one required condition, remember, is that the sample size multiplied by the proportion has to be higher than 5, and the sample size multiplied by 1 minus proportion also has to be higher than 5, and typically is in all cases, in most cases, okay? So let's take a look at one problem. We have survey of women golfers. A national survey of 900 women golfers was conducted to learn how women golfers view their treatment at golf courses in the US. The survey found that 396 of the women golfers were satisfied with the availability of tee times. Now, suppose one wants to develop a 95% confidence interval estimate of the population proportion of women golfers that are satisfied. Okay, so here look at that 95% confidence interval. So what is the z-score associated with this 95% confidence interval? If you remember, we have three most used cases. 95% is one of the most used, is 1.96. We computed that, but if you don't remember or recall, you can compute that using Excel. Okay, so let's take a look at the steps I propose to help you solve this problem. First, take notes, check the conditions, compute z alpha level divided by 2 as we learned in previous videos, plug the numbers into the formula, interpret the interval estimate. So if you do by hand, this is how you would organize your answer in a notebook. You compute the sample proportion of satisfied women, which is the amount of women satisfied, 396 divided by 900, which is the total sample, which gives us a proportion of 0.44, and then all other information is given in the problem. Check conditions like multiply the sample size of 900 by the proportion of 0.44, and you get 396, which is higher than 5. And if you multiply 900, the sample size, multiply this number 900 by 1.1 minus 0.44, which is 0.56. The resulting number here is 0.56. You get 504, which is higher than 5. So you check the conditions, that's fine. The z-score is 1.96. You plug the sample proportion here, 0.44, and you add and subtract this resulting multiplication here, the standard error multiplied by the z-score. So let's take a look to see how to do that in Excel, just to demonstrate in Excel. So first step 1, finding the proportion. Let's see, finding the proportion. I have women satisfied, which is 396, sample size 900. So the sample proportion is equal to 396 divided by 900. Okay, so that's the first step. Step number 2, check the conditions. So n multiplied by p is equal to n multiplied by p. N multiplied by 1 minus p is equal to n multiplied by open parentheses 1 minus p. Okay, step number 3, z is equal to 1.96. You have a video about how to find the z, I'm not going to do it here. Step number 4, add the numbers. So you have the sample proportion, which is equal to 0.44. You can type that so you don't have to select the cells. And then you have the margin. Let's compute the margin of error. Let me do this here, margin of error. So the margin of error, okay, let me get the standard deviation of sample proportion. Okay, so the standard deviation of sample proportion is equal to the square root, right? The square root of p multiplied by 1 minus p divided by 900. So square root, I'm going to open parentheses again because I want to do this multiplication on top. So it's 0.44 multiplied by, open parentheses, 1 minus 0.44, close 2 times the parentheses, and then I divide by the sample size, which is 900. I close parentheses, and the sample standard deviation of sample proportion is 0.016546, and the final margin of error is equal to this sample standard deviation of sample proportion multiplied by this. Now what I have to do is add and subtract. So step number 5, no, I'm still on step number 4. So let's put upper limit is equal to sample proportion plus final margin of error, 0.47, like here, and the lower limit is equal to sample proportion minus is 0.40, almost 0.47. So if you reduce the decimal places here, that's the final answer. Okay, and then you interpret, and that's it. This is how you solve it. Let's see. You can practice. Let me go to the book, our book, MindTap. Let's open MindTap. MindTap is closed here 2 times. Let's access MindTap. I want to show you how to find some problems to work on, just to help you find other resources and give some incentive for you to look for. So here in chapter 8, you can go to population proportion, open here, and then you have this menu. You go to exercise applications, and you have many problems with the answers for you to work on. Also, you have videos here, videos in practice, show me the solution methods and applications. There are many resources for you. So I hope you can find all the answers you need. Okay, that's all for interval estimate. And that's all for this section of the book.